Let's return to the tire company problem and find a p-value. We were testing the tire company's claim that the average life of their tires was at least 80,000 miles. We found that the sample average was 78,500, which has some evidence against that tire company's claim. Now, we want to go ahead and see if that evidence is strong enough to determine if we can go ahead and say that their claim is false. And we ran a hypothesis test. Now, in doing that, we calculated for the 78,500 a test statistic. Our sampling distribution is built assuming that the null hypothesis is true with 80,000 in the center. The test statistic places the 78,500 so far to the left of the 80,000 that it's almost an outlier. So there is a high probability that 80,000 is not in the center, and therefore we can say that the null hypothesis is incorrect. The p-value is the probability of observing a value of the test statistic that is at least as contradictory to the null hypothesis as the one computed from the sample. So my p-value is the probability of getting anything less likely. And to calculate that p-value, I'm going to look up the negative 2.87 in the normal table and find the area to the left. So going down to row 2.8 and then to column 0.07, I get 0.4979. So for a z-score of 2.87, I'm going to get a probability of 0.4979. Now by symmetry then, my p-value would be equal to 0.5 subtract 0.4979, which equals 0.0021. So we'd say the p-value is equal to the probability of z less than negative 2.87, which is equal to 0.0021, which is less than 0.05. So again, reject h sub 0. So the p-value is the probability of observing a value of the test statistic that is at least as contradictory to the null hypothesis as the one computed from the sample. And that probability for us is 0.0021 or 0.21%. That is less than the maximum risk we were allowing ourselves in making a type 1 error of saying that the null hypothesis was wrong and in reality it ended up being correct. Notice that looking at the p-value and comparing it to alpha, the level of significance, results in the same conclusion as comparing the test statistic to our z alpha value. So we are rejecting the null hypothesis because the location of the 78,500 at 2.87 standard deviations to the left is further out than our decision line at 1.645 standard deviations to the left. So the 78,500 is far enough away from the 80,000 to reject the null hypothesis. We can also see that our p-value, 0.0021, is less than our level of significance, alpha, 0.05. So in rejecting the null hypothesis, we're taking even less risk than we were willing to take and are more confident in this case that the null hypothesis is incorrect.